Greetings to all the students. Welcome to biology and chemistry lessons. And our today's topic is periodic table, group 1 alkali metals properties we will see. And this is one of the very important chapters of our O-level IGCSE Cambridge chemistry syllabus. So the students of class 6, 7, 8, 9, 10, they all have to know the properties of periodic table and specifically the properties of groups and periods. So let's start. What are group 1 elements? Group 1 elements are called alkali metals, and there is a reason behind it. Why do we call them alkali metals? So first of all, let's see what are group 1 elements. They are lithium, sodium, potassium, rubidium, cesium, and francium. So if we make the electronic configuration, we know the atomic numbers. The atomic number of lithium is 3. So lithium's atomic number is 3 and the electronic configuration is 2, 1. Similarly, sodium electronic configuration will be atomic number is 11, so 2, 8, 1. And potassium 19, so the electronic configuration is 2, 8, 8, 1. So what common thing you can see in all of them? At the end, there is 1. What does it mean? In all of them, you can see there is 1 electron in the last shell. And this is the reason that they all are the members of group number 1. So whatever the elements are there in group number 1, if you make the electronic configuration, they all have 1 electron in their last shell. Another thing, interesting thing which we can notice here is that in case of lithium, there are only 2 shells. So you can see 2 shells. Sodium 3 shells, so 1, 2, 3. Potassium 4 shells. So 1, 2, 1, 2, 3, 4. Similarly, after potassium, rubidium 5 shells, cesium 6 shells, francium 7 shells. It means when we are moving down the group, 1 shell is increased. And we have learned in the previous session of periodic table that the number of shells represent the number of periods. They all belong to group number 1. The reason is that they all have 1 electron in their last shell. But every element is a member of a different period. How? Lithium has 2 shells, so it is in period number 2. Sodium has 3 shells, so it is in period number 3. Potassium has 4 shells, so it is in period number 4. Similarly, rubidium is in period number 5. Cesium 6. Francium 7. So they all are the members of the different periods, but at the same time they are belonging to same group number 1 because they all have 1 electron in their last shell. Another thing we can say that group number 1 elements have 1 electron in the last shell. So in order to get the noble gas electronic configuration, what is noble gas electronic configuration? 8 electrons in the last shell or 2 electrons in the first shell. In order to get the noble gas electronic configuration during the chemical reaction, they all lose 1 electron. So when they all lose 1 electron, what will happen? Lithium, if lithium loses 1 electron, so lithium has got only 1 shell left and it has 2 electrons. So you can see first shell 2 electrons, but it will get a 1 plus charge over it because losing electron will give a positive charge. Similarly, sodium, if it will lose this 1 electron, so it will have only 2 shells left. And the second shell has 8 electrons now. So noble gas electronic configuration is complete. Plus 1 charge. Similarly, when potassium will lose 1 electron, potassium's last shell will be the second last shell and it has 8 electron and it will get a plus 1 charge. So it means they belong to group number 1 means during the chemical reaction, they lose 1 electron. Why? Because they have to achieve the noble gas electronic configuration and in doing so, they all get a plus 1 charge. You can see when we are moving down the group, 1 shell is increased. It means the ability to lose the electron increases down the group. What is the ability to lose the electron? In one word, we can say reactivity. The one which will lose the electron quickly, that will be more reactive. The one which will lose the electron slowly, that will be less reactive. So you can see this is the nucleus of the lithium, of this lithium, and inside the nucleus there are protons. Electrons have got a negative charge, protons have got a positive charge. It means the electrons are attracted by the protons. So you can see the distance between the nucleus and the last shell of lithium is less. So the attraction will be more. So lithium will lose the electron, but it will be needing more energy to lose the electron. See the example of sodium, one shell is increased. The distance is increased, or you can say the atomic radius has increased. And so the attraction from the nucleus is decreased. So sodium will lose the electron easier than lithium. See potassium, one more shell is increased. Atomic radius is increased more. The attraction from the protons inside the nucleus and the last electron is decreased even more. So potassium will lose the electron more faster instantly than sodium, and sodium than lithium. It means the ability to lose the electron is their reactivity, and since the size of the atoms increases down the group, the ability to lose the electron increases down the groups, or we can say the reactivity increases down the group. So when we are moving down the group, they become so much highly reactive that they are almost explosive in nature, and overall they all are so highly reactive in nature that explosively they can react with oxygen in the air. When they come in contact with air, they can react explosively with water, they can react explosively with acids. Even when we touch them, they can even explode in our hands because we have moisture in our hand. This is the reason that in the laboratories we keep group number 1 elements under paraffin oil, so that they may not come in contact with air or water or anything. Otherwise, they will explode. Now you can see how they are going to react. Their peculiar nature is that they all, when they come in contact with air, they burn with colorful flames. So you can see this is the example of lithium. Lithium is, when it comes in contact with oxygen in the air, it burns with a beautiful red color flame. This is sodium. Sodium burns with a yellow color flame. This is potassium. Potassium burns with a lilac color flame. So when they come in contact with oxygen in the air, they burst into colorful flames, and this is the reason that they are used in firecrackers, in fireworks, because first of all they are explosive in nature, and then they burn with colorful flames, so they are used in fireworks. So you can see when lithium is reacting with oxygen, these are the chemical reactions. You should know the chemical equations, you should know the balancing of chemical equation, and you should know the state symbols. You can see with every element this S, G, O in the bracket representing the state symbol. It means lithium is a metal. All the metals except mercury are solid, so it is solid. Coming in contact with oxygen in the air, which is a gas, and it is forming lithium oxide. Sodium is forming sodium oxide. Potassium is forming potassium oxide. So the metal oxides, this one, this one, this one, these all metal oxides are given a particular name which is called base. So what is a base? Metal oxides are called bases. It means when group number 1 elements come in contact with oxygen in the air, they burn with colorful flames and they form white ashes of lithium oxide, sodium oxide, and potassium oxide, and these ashes are called bases. Now see what happened when they come in contact with water. You put them in a small piece of lithium, sodium, and potassium in water. So this is lithium, this is sodium, this is potassium. You can see lithium is floating on the surface of the water and it is fizzing. Bubbles are coming out. The reaction is a bit slower. Same size of same mass of the piece of sodium, it will start shooting across, jumping over the surface of the water, and it is showing yellow color sparks. Same small mass of potassium, if you put it on the surface of the water, it catches instantly, it catches fire and start burning with a lilac color flame. It means lithium is comparatively less reactive than sodium, and sodium is comparatively less reactive than potassium. We can understand by seeing the observation. What happens when they come in contact with water? When they come in contact with water, you can see the chemical reactions over here. When lithium is coming in contact with water, it is forming lithium oxide and the phase is for hydrogen gas. Sodium is reacting with water forming sodium hydroxide aqueous solution and a phase of hydrogen gas. Potassium reacts with water and forms an aqueous solution of potassium hydroxide and a phase of hydrogen gas. We can see the observation that reaction is slower than water than sodium. You can see the bubbles of hydrogen gas, and slowly due to the heat of the reaction, since it is an exothermic reaction, so heat is produced. So lithium, due to the heat of the reaction, melts and disappear. Sodium, when you put a small piece of sodium, you will see the bubbles of hydrogen gas. Sodium melts into a shiny ball, dashes around the surface of the water and then disappear. Sodium floats on the surface of the water because it is less denser. And then hydrogen gas is given out. Then it catches fire because exothermic reaction. Potassium reaction is more violent than sodium. It also gives bubbles of hydrogen gas. It also melts due to the heat of the reaction and disappear. And then gradually you can see that it is burning over the surface of the water with a blue color. So these aqueous solutions like sodium hydroxide, lithium hydroxide, potassium hydroxide, so these aqueous solutions are called alkalis. So now we can understand why their name is alkali metals, why they are called alkali metals, because when they react with water, they form alkaline solution. What is an alkaline solution? These hydroxides in aqueous form are called alkalis. So this is the reason that we are calling them alkali metals. Now, these are the chemical properties. Now let's move and see some of the physical properties. So what are the physical properties? The physical properties are they are pure metals. Why the reason we are calling them pure metals? The only reason is during the chemical reaction, they lose the electrons and get a positive charge. This is the typical properties of all the metals. During the chemical reaction, metals lose the electron and they have a positive charge over them. They are different from the traditional metals. Why? Because the traditional metals, like when we think about iron, silver, gold, copper, aluminium, we think that they are very hard, tough, strong, shiny. But on the other hand, these group 1 elements, they are so soft and fragile that they can cut with knife. If you think about iron, silver, gold, if you put a small piece of iron, it sinks in the water. But unlike these traditional metals, they float on the surface of the water because their density is very low. They have low melting and boiling points. They have one electron in their last shell. During the chemical reaction, they lose one electron. Why? Because they have to achieve the noble gas electronic configuration. It means they have to achieve 8 electrons in the last shell. So in doing so, they get a valency of +1. And moving down the group, since the size of the atom is increasing, their reactivity is also increasing, because when the size of the atoms increases and the valence electrons, they go away from the nucleus, it is easier for them to be, to lose the electrons. Why? Because the attraction from the nucleus decreases with the distance. And they all are typically explosive in nature and they burn with colorful flames. So these are all the properties of group number 1. In the next class, we will see the properties of group number 2 and we will compare the properties of group number 1 and group number 2. That is all for today. See you in the next class.